2.3 Fatigue and Recovery by Edward Sayers. What is fatigue? Fatigue can be described as extreme tiredness resulting from mental or physical exertion or illness. Symptoms of fatigue can be both physical and mental. Some physical symptoms include feeling extremely tired, having achy muscles or joints, feeling pain in areas that may have been worked too hard or overtrained possibly during training or matches. This also links to us feeling sore and possibly not being able to move properly because of the pain that we are experiencing. Psychologically, we can also feel drained and we have no desire to do anything and just want to sleep and relax, which arguably is the best thing to do because therefore it will allow us and our bodies to recover. Overall, the symptoms of fatigue that we feel really do depend on the intensity and duration of the exercise that we've partaken in. Because if we participate in exercise or an activity that has a long duration but low intensity, for example a marathon, we would feel different symptoms of fatigue to what we would feel if we did a 100-meter sprint, which is a high intensity and low duration. Fatigue is caused by several different factors. One of these factors could possibly be a lack in oxygen being supplied to our working muscles. If our muscles are working, they need to be constantly supplied with oxygen to keep them contracting. However, if you fail to provide the muscles with enough oxygenated blood, then they will be unable to work and contract, which is what we need them to do. Another cause of fatigue could possibly be a build-up in lactic acid. Lactic acid acts like a poison and changes the pH of the muscles in our body, which our body can sometimes find difficult to cope with because our body likes homeostasis, which is for everything to stay the same. The change in pH and the rise in the acidity causes almost like a burning sensation in our muscles, which can cause athletes to slow down and lower the intensity of their exercise. There are also psychological factors of fatigue, such as a lack of sleep. This can lead to people feeling fatigued quicker than they usually do. There are three different types of fatigue. These are localized, general, and chronic fatigue. Localized fatigue is fatigue only in certain muscles from doing repeated contractions. For example, if you're doing a pull-ups exercise, you would be constantly using your biceps brachii to pull you back up. The constant use of this contraction in these muscles will make them become very fatigued quite quickly, actually. The second type of fatigue is called general fatigue. This is the feeling that people get after a tough game or training session where they feel physically and possibly even psychologically weak. This is because you've been using a wide range of muscles and you've been using a lot of energy to do this exercise, so therefore you feel very drained and fatigued afterwards. Lastly, the third type of fatigue is called chronic fatigue. This can be experienced because of excessive overtraining or possibly even inadequate recovery, meaning that possibly not getting enough sleep and rest can lead to this recovery, and that means that you might not be able to get the full amount of rest and recovery that you needed from doing the previous activity. Chronic fatigue can lead to a weakened immune system, which can therefore lead to you being more susceptible to illnesses possibly. If we look at different types of events, we will be able to see how the intensity and duration of the event can influence the amount of fatigue that we would feel. For example, a shot put thrower, you would only use the ATP that is stored within your muscles already, but this would become very soon depleted. The ATP would soon become ADP, and so in the recovery, your aerobic system would resynthesize the ATP almost instantly. As a shot put thrower, you would feel almost no fatigue. You may feel a bit of localized fatigue in your shoulder area possibly, but it's quite unlikely. You do numerous throws one after another, but ultimately, due to the very short duration of the event, it is unlikely that there are any symptoms of fatigue that you will actually experience. Due to there being no or very minimal fatigue, it is unlikely that there would be much of an effect on a shot put thrower's performance. If you did lots of throws repeatedly, the distance of the throw may decrease due to some localized fatigue. But if you only did one or two throws, like most people do in an Olympic shot put throwing event, it is likely that performance would not really be affected that much. As there will be no fatigue experienced, it is likely that there would be no need to rely on any other component of the EPOC as a shot put thrower. However, we would need to suggest that if we were doing continuous throws one after another, we would need to use the fast component to help resynthesize our ATP stores. Recovery would last seconds, and the aerobic system would resynthesize the ATP very easily. In a 100 meter sprint, on the other hand, which is also a very maximal intensity event and which has a very short duration, you could possibly feel many different symptoms of fatigue. The activity would use our ATP system and also our PC phosphocreatine system, and so both would need to be resynthesized after the event in recovery. The waste products of this event would include ADP and phosphorus and creatine. The symptoms of fatigue would kick in after the event has finished, and so the performance of the athlete would not be affected during the race. However, if they had done numerous sprints before their event, their performance would rapidly decrease, as they would not be able to run as fast due to the ADP build up, and the fact that there would now be ATP, and the fact that the ATP and PC system would have been depleted of their stores. Fatigue can be reduced or possibly even avoided by using phosphocreatine supplementations to aid you in exercise. By taking these supplements, you can increase your time. You can increase the time that you are working 100% anaerobically at the highest intensity possible. So as you can see on this graph, the slightly shaded in colour is an athlete that hasn't taken a PC supplement, and the one that's coloured in black is someone who has. So as you can see, the person who hasn't has a much lower PC stores within them, and the second half of the graph shows the two athletes' PC stores after the event. So as you can see, person 1's PC stores are much lower than person 2's who has taken phosphocreatine supplements. So they both have depleted, but person 1's PC stores have depleted a significant amount more than the person who has taken PC supplements. So on this graph you can see that different sections of it are labelled. You can also see that there is a key in the top corner. On the graph you can see that it begins flat and then goes up via a rapid increase. It then plateaus, and then there is a steep decrease. This rectangular shape is supposed to represent a human's VO2 intake if they could work anaerobically perfectly. Unfortunately, our bodies are not capable of working 100% aerobically for long periods of time. This graph shows the epoch whilst undergoing maximal exercise, for example, a 100 meter sprint. The epoch is excess post-exercise oxygen consumption. So it's basically the VO2 consumed or used above resting levels in recovery, not just the oxygen that we breathe in. The area of the graph labelled C is where we will begin. As you can see from the key, this is called the O2 consumption during exercise. So this is the amount of oxygen that we intake from the surrounding atmosphere and take into our lungs and our body. As you can see on the graph, it has a steep increase as we begin to take in more oxygen at the beginning of exercise. The little space left in the top left corner, lettered E, is the O2 det. This is the oxygen in the surrounding atmosphere that we have not inhaled. If the O2 det, if there is an O2 det, then this shows the VO2 is insufficient for the demand of the activity, because not all the O2 from the surrounding atmosphere has actually been inhaled. Once the event has finished, the athlete must now recover and restore their body's stores of ATP and phosphocreatine, depending on the duration of this exercise, because if it's longer then they might need to restore other stores because of using different fuel sources. As you can see on the graph, there is a drop in the athlete's VO2 consumption due to them stopping the exercise. The section of the decrease labelled A is your alactic fast recovery component. This is the restoration of your ATP and phosphocreatine stores after using your ATP and PC's energy systems. Using your aerobic system, your aerobic system is reattaching the phosphate bond to both the ADP and creatine to resynthesize the stores of ATP and PC. The section of the graph labelled D is what's called your lactacid slow recovery component. This is the restoration of your lactic acid system and possibly your aerobic system. In all activities, there is never just one energy system working. All systems work simultaneously, however some are more prominent during different intensities and durations. For example, during this example, a 100 meter sprint, an athlete will dominantly be using their ATP and PC systems because the duration is between 9 and 11 seconds. However, their lactic acid and aerobic systems will be working in the background also. So the section of the graph labelled D is the lactic acid and aerobic systems resynthesizing, and the area of the graph is very small because they were the less dominant energy systems during this event due to it being a maximal intensity and short duration event. Due to the duration of the exercise and intensity, the athlete will mainly be using their alactic fast recovery component to recover. This will take 2 to 3 minutes to fully recover, and if the athlete has just participated in a marathon, for example, they would mainly be using their alactic and aerobic systems, and these, like I said, would be recovered by the lactic slow recovery component, which can take between 2 and 48 hours to actually fully recover. When we analyse a 400 meter sprint, we can see that there is a difference between both the intensity and duration of this event compared to a 100 meter sprint or shot put throw, for example. This event would require us to use our ATP and PC systems like last time, however this time also our lactic acid system. The source of energy that would be required would mainly be carbohydrates, and the waste products would include ADP and phosphorus. So the RER reading on this graph would show an event like a 400 meter sprint with its intensity and duration to have a reading of around 1.0, since they're relying on purely carbohydrates as a fuel source. During an event of a moderate intensity and a moderate duration like a 400 meter sprint, an athlete's liver glycogen will deplete. Liver glucose is important due to the fact that it helps produce blood glucose, which is essential for the brain. Muscle glucose acts as a fuel for our muscles to contract, and therefore an athlete's glycogen stores deplete. Their overall performance will be directly affected because of this. By using the lactic acid systems, there are repercussions that can affect an athlete's performance. For example, by using this system, there will be a build-up in the production of lactic acid in the athlete's muscles. The lactic acid contains hydrogen ions that, if are left in the muscles, can cause an athlete to experience pain since they are highly acidic. A person's OBLA is their onset of blood lactate accumulation. It is the point at which blood lactate accumulation becomes extensive enough to suppress performance. The point of OBLA depends on the level of training of the athlete, but averages to about 4 millimoles. As you can see on the graph, for the millimole, the 4 millimoles is marked here. For an event like an 800 meter sprint or 400 meter sprint, which is considered to be a moderate duration and moderate intensity exercise, an athlete will want to prolong their OBLA so that they don't reach their so they don't start to build up lactic acid too quickly. The point at which they this is their lactic acid their lactic acid threshold, and this is the point at which they begin to build up lactic acid. This is the point where they begin to use their lactic acid system. The lactic acid increases, which lowers the pH, making it more acidic. Then this inhibits enzymes activities in glycolysis, and therefore prevents breakdown of glucose, and this induces fatigue. This process of muscles fatiguing due to the increase in lactic acid buildup means an increase in hydrogen ion production, which again are highly acidic and will induce pain for an athlete. An athlete that completes an event over a long duration will train their bodies to prolong their OBLA even more, to make them able to exercise for longer before they reach their lactic acid threshold and begin to use their lactic acid system to produce energy.